Alright guys, second part to this success criteria about deriving the linear rule from a graph. In this video you're going to have a look at how to find both the y-intercept and the gradient. Okay, the y-intercept, if we look at our y equals mx plus c, the y-intercept part refers to this, and again if we were to look at our y equals mx plus c, the gradient refers to this part here. Okay, once we find those two, we can then write our equation. So first of all, we've got that graph, same one that we had on the last video, and I've just marked where we can see down here where that line crosses that y-axis, okay? This one here being the y-axis, of course, and the one over here being the x-axis. Now, each time we draw a straight line, we can only cut that y-axis once, all right? And it's found via inspection. In year 8, you guys are just going to observe a graph, or inspect a graph, and state the y-intercept. Okay, so in this case, the y-intercept here equals 1. All right, so now, as we set up here, when we find that y-intercept, that refers to that c component of that equation. So now we can come in and start substituting. Instead of y equals mx plus c, we've now moved to y equals mx plus 1. All right, just to see how that would change, if that line was to come through here and it was to cut at -2, okay, we would have an equation that starts looking at y equals mx, and because it's -2, we would just have take 2 on the end of it. All right, just so you can see the difference from that. It can be plus c, it can be minus c as well. Moving down here now to the gradient, which we know refers to the steepness of the line, and it can both be positive, okay, or it can be negative, depending on which way the line is going. If you have a line running this way, okay, that will give us a positive gradient, which is that m part, okay? If, however, we have a line traveling down this way or up that way, this will give us a negative gradient, okay? So the m will be a negative value. Now, how we find m, okay, is by looking at our line, and we need to find 2 points on that line, because to find the gradient, we've got to take the rise between 2 points and divide that by the run of 2 points. So, to explain that, rise is obviously this way, and run is obviously across this way. So what I'm going to go do now is pick 2 points on the graph, and you can see I've picked a point there which lines up nice and neatly with -2 and -3. This one here possibly might not be as easy to use, but you can find another one just here as well which fits nicely in -1, -1. Now I'm going to pick another one, and I'm just going to go and pick, let's say, this one right here. Okay, so that's at 1, 3, and we've got the one down here at -2, -3. Now what we can do is that we can actually draw a little triangle which links these together. Okay, what we need to do now is we need to look at the rise, so how far we have gone up to here from down here. Now I can count from here 1, 2, 3, 4, 5, 6 to get to there. So that's my rise. My run is from here across to just here. All right, and I can see that is 1, 2, 3 units. 6 divided by 3, that gives us our gradient of 2, which is our m value in our y equals mx plus c. So now really important is this point here and this point here, because what we can do now is in our form of y equals mx plus c, y will remain as y. My m I now know is 2, that goes with my x, and my y-intercept up here was 1. So I can now go and write my equation as y equals 2x plus 1.